Okay, you guys can see the first question. And I'll get started. Let me know when you start. I'm gonna forcibly wait. Can I forcibly mute people? Fuck, I don't have moderator in here, so I can't like forcibly mute people. Oh my god, this is gonna be such a struggle. Okay. Well, let's get started. This was a question that he actually showed us in class. Are you recording right now? Just give me a sign. Okay, hell yeah. So this is a question he showed us in class. It's remove duplicates. In Scheme and Prolog, create a program that removes duplicates. You're given a list and you're asked to remove duplicates. So my tip for Prolog questions is just get the base cases out of the way. So what a base case would be if you're removing duplicates. Well, if you have an empty list, you want to return an empty list because there's no duplicates within that list. Okay. Another case would be when you have like this, when you have like a list that has like 3, 3, 4, etc., where this first character is the same as the head of the, like it's the same as the head of the tail. In this case, you would want to remove dupes. You take the list and you split it from head and the rest of the list. And then you have L, which is your response, your answer. And you want to check if this head of the list is a member of the rest of that list. So you would actually use the member function within Prolog, and you're comparing the head with the rest of the list. So if you know that there is a duplicate of the head within the rest of the list, you're going to call or return remove dupes, and you're going to give it A and then R, and this would actually be R as well. So basically what this in essence is doing is you're checking if, I'll just give you a different example here. Let's say you have a list that has 3, 4, 3, 5. You're taking the start element, which is E, and you're comparing it to see that if it has an intersection or if it's within this set. And you see that E exists within this set. So if it is a member, you're going to take off E and return A, which is the rest of this list, as your result. Okay. Let me just this explanation. And then there is one last base case. So we're gonna remove dupes. Okay. We have E, A. We're gonna leave this result, whatever return, blank for now because we currently don't know what is gonna be in there. We have the case that it is a member. Is a member, which basically means is duped. And we have the case where there's nothing in the list. So now we need to cover the case where it is not a member or it's not a duplicate. So in this case, we have E and A, and we're trying to see, okay, is not member E and A. So if E is not within A, what you want to do is you want to call this recursive function, remove dupes. You want to keep the same thing with A and R because you still want to check the rest of the tail, right? But you know that E is by itself. There's no duplicates of E. So you actually want to add this to the result. So this is why we fill this in with E and R. This, you're basically concatenating E to the result, to the end result. And that is all for this question. So actually, let me make that as a note. E, which can be an element, to result. Okay. Because it not duped. So I know some of you guys do want to follow along with me. If you do, in the IEEE channel, I'm actually gonna put the PDF in right here, and you feel free to download it and follow along. Does anybody have any questions about this example? We're also going to be doing it in Scheme, and I'm going to show you how you can quickly convert a Prolog question to a Scheme question. Alrighty. Feel free to interrupt me if you do. Okay, let's keep going. So now we're going to do remove dupes in Scheme. I'm just going to make a quick note. This was shown in class, but also it is in the labs. So if it sounds familiar, you've probably done it before. And it's a really nice solution because you're basically using almost tail recursion to keep track of the non-duplicated elements. So let's just compare it. We're going to use the same cases that we have here before. The first case is nothing in the list. Second case is a member. Third case is not a member. Within Scheme, they give us the start of the function and we have to complete it. So we're going to do a con statement or a conditional statement, and we're going to have 3 to 4 conditions. So our first condition is if the list is null. If that list is null, we're going to return an empty list. And that's, if you go up here, it crosses off this first case. Okay, second case. Let's say if we only have one element. One element, we're going to return that element. So let's see this. Null. How do you check if we only have one element? Well, you do CDR of L. And then you can return L. Because you know that it is only one element. Last item. Does everybody know what CDR and car are in Scheme? Speak now or forever hold your peace. Okay.
I'd actually like to ask a question on the null case, like completely empty. What's within the return for that null bit? There's apostrophe, open bracket, something, some bar, and then close bracket.
Right here?
Yeah, what's that? Yeah.
Okay, so this is actually returning an empty list. So in Scheme, in order you can do, I think there's 2 ways to make a list. You can do lists, right, and create something as a list. So if you do list A, it converts it to a list. Or you can just go right ahead and say you're gonna create a list by this statement.
Oh, okay. It's a bracket. I see. That's all I need to know.
Exactly.
Oops.
Sorry.
Thought there was like an L or a 1 or
Oh,
something.
my bad.
But it's a bracket.
Let me just write that a little. Well, okay.
Cool and good. Thank you.
I'm just gonna. No problem. I'm just gonna go quickly over car and CDR. Car, you're taking the. Okay, you know how we have head and tail in Prolog? When you're doing car, you're taking the head. When you're doing CDR, you're taking the tail. And I'm gonna go over some more review of those things and like variations of them later down in the slide. So we have the 2 cases. We have the first case where the list is empty, we're returning an empty list. And then we have the second case where it only has one element and we're returning that rest of the list. Now we're going to check the case where there is a member that is duplicated. Or actually, let's check the list where it is not a member. And it is not. Actually, no, let's check this one first. Let's just go in order, whatever. Okay. So we're going to use equal. And we're going to check the first element of the list. And we're going to check the first element of the tail of the list. And then if this is true, we are going to remove dupes. And we're going to keep it with the rest of the list. So we're basically doing this function, but in scheme. You can summarize this statement by saying CA dr, right? This is equal to car, and then CDR. I'll go more in depth in that later. Does everybody understand this line? Basically, we're comparing the start of the list. This is start / head. This is head of the tail. And we're checking if they're equal. If they're equal, we're going to call this recursive function with just the rest of the list because we're removing that duplicate. Okay. Now, this is our last conditional, and it's going to take in this other case. We have is where it is a member, now where it's not a member. So else, what we're going to do is we're going to cons the car of L, right? We're going to take the head of this list and concatenate it with remove dupes of the CDR of L. Basically, as the recursive call collapses, we're taking every single unique element and consing it with the result. When the recursive call collapses, we're going to return all the unique elements, so LM1, LM2, LM3. They're all going to be concatenated together, and that will return at the very end. That's why we're like, pretend that we already are thinking like 400 steps ahead, and this is the answer. Right? Because all these statements, all these recursive calls will return a singular element, right? That can be concatenated to this one. So we're concatenating an element, a unique element, to the answer. Does that make sense? This was actually a lab question, and it's very important to review because it gives you a nice concept to deal with.
I have a question.
Yeah, for sure. Go.
Isn't the condition where it's checking if there's a duplicate, isn't it only checking like the following element and not the rest of the list?
Yeah, it is only checking the following element.
Okay. So yeah.
You're right. Let me check. Let me think if it actually would affect.
Like, I mean, we have to use a member. I think there's a member function for C. We might have to use like another function to check if it's a member of the rest of the list.
Yeah, I think that is another solution. Actually, I have all of the solutions.
This would only work if the list is sorted.
That's true.
Right.
That's true. And there is a sort function in Scheme. Yeah, I think there is here. I'll also probably give you guys this at the end of the day. Let me just quickly get Dr. Ratchet open. But I have summarized all the labs of the class. I have Monday section labs, so I don't know if I did all of them. And it's this one. If I put this on my screen, can you see it? Yes, you can. But I have went through and summarized all the labs and all the solutions that were provided and all of my solutions. And I will probably give you this at the end of the day for more scheme review. But yes, you're right. There is a member function. I could probably just make a squeeze in a function or a let rec because we're doing recursion. let rec where you let L be the sorted list or whatever. But that is my solution, and that was the one that was provided in class. Okay, let L be sorts L. I'm pretty sure that is how you use sort. I will double check.
If you want to sort it before calling the algorithm, you gotta do like an auxiliary function.
Okay.
Because then you would have to sort it as at each call of the list with the letter.
We'll fill in later. Okay. Now we're on to some of these questions. So our professor, I think we have the same exam as the French section, and he said some of the questions he's just gonna give us a scheme function or any function, and he's gonna give us all the logic and just ask us to write the recursive call. So in this function, let's see what's happening. Right now we have the union of L1 and L2, and we have conditional statements. If L1 is empty, we return L2. So let's just say this is L1, L2. If L1 is empty, we're returning L2. If L2 is empty, we're returning L1. Else, we're going to member the start of L1 with L2, and then call the union on the rest of the list. So essentially what we're doing here is that we are combining if it's not a member. Okay, this is if head of L1 is unique to L2, add union. Okay, if it's not a member, I'm pretty sure if this is saying if head of L1 is unique to L2, is not unique, then take the rest of L1 and check the union of it. So this is dealing with when it's not a member, so I'm guessing this case will deal when it is a member. When car L1 is okay, the not statement is triggering my head right now. This is when it's not unique. This is when L1 is unique. And in this case, basically, we're going to take L1 and do almost what we did in this question, where we're consing L1 with the rest of the answer of this recursive call. So we're going to cons the car of L1, because we know now it is a unique element, and we're going to add that to the rest of the union, and then CDR L1, and then L2. Alrighty. Does that make sense for everybody? I feel like my explanation was a little... If nobody interrupts me, I'll just keep going. Alrighty. He will probably give us a couple questions like this. They're pretty simple. Just understand the logic, understand what the question is asking you to do, understand what the previous cases are asking you, and then you can fill out the last one. Okay. So now we're going to create a Prolog problem, or a function that does the following. You take two lists, and you merge the contents so that it is in ascending order. And they give us an example. Okay. So what I said with Prolog, you want to deal with the base cases first. So one of the base cases that I think about instantly is that if one of these lists are empty. So if one of those lists are empty, you're just going to probably return the other list. So let's see. Merge. Let's say the first one is empty. You're just going to return the second one. let's say the second one is empty. You're going to return the first one. Okay. And now we have to think about some examples. Merge. Let's say that this first element is less than this first element. So like in the same example. Like this head is less than the head of the other list. So we have head 1 of the first list, and then tail 1 of the first list. And we have head 2 of the second list, and tail 2 of the second list. And then we have a result that I'm going to leave blank for now. If head 1 is less than head 2, we want to merge with the rest of the tail of head 1, of list 1, and keep the list 2 the same. And then we have our result. In this statement, since head 1 is less than head 2, and we're sorting in ascending order, we're going to add head 1 to the result. Does that make sense for everybody?
Yeah.
Okay. Perfect. Now we're going to do the case where head 2 is actually greater than head 1. So we have the same start. And then you're probably also going to realize you're returning head 2, because that is the case that we're dealing with. And now we just switch these. You know that it's head 2 is greater than head 1. And you're going to merge. You're going to keep this the same. Head 1, tail 1. You're going to take only the rest of the second list. And you're going to keep the result. Okay, that is that question completed. Does anybody have any questions about this, or can I continue?
I think it should be head 1 is greater than head 2.
Oh, yes, I switched them. Thank you. Thank you. 1, head 2. Yes. And make sure you end these off with a period. I'll probably forget that during the final. Okay, does that make sense? We're good. Okay, we're going to create a program function, a Prolog that function that does the following. We're going to slice this list. You're going to start at index 1 and go to index 3, and then return L. So in this case, 0, 1, 2, 3. We're returning this list. We know that this is inclusive. And they also give us a hint. If the number of elements from given index is less than the number that is within the list, give the rest of the list instead of an out of bounds error. Okay. So the same thing, we're going to start with the base cases. So we know that one of the base cases is that if here, let's say that they are asking for the number of elements, but the number of elements that they want is 0. So if this number is 0, no matter where we start, we would return an empty list. This is list, this is index. Let's say this is the number. The number they want is 0. We're just going to return an empty list. Okay. The second question, how about if this list, or the second base would be if this list is empty? If this list is empty, we're just going to also return an empty list. Okay, perfect. Now it's time for the fun part. So my initial thought is if you're going to code this in like Python or something, you're going to loop to the correct position within this list and then start dissecting it. So I'm just going to name these variables so I don't have to reference them. We're just going to call this I, we're going to call this n for now. So if this was a regular function, you're going to take this list, you're going to go loop through it n times to find the section that you actually want to take a slice out of. And then you're going to proceed to take a slice out of that list. So this is going to be the part where we're going to loop to the correct index. So we're taking a slice, and now we're going to actually split this into head and tail. We have an I value, we have an n value, and we have the result. So we're going to do some checks. We're going to make sure that we actually have an I value and we actually have an n value that is greater than 0. So n greater than 0, I greater than 0. Okay. Now we're going to de-increment I because we're sending out the rest of the list that we actually want to deal with, right? We're doing this action. So what we're going to do is we are going to say that I1 is I minus 1. And then we're going to slice. We're going to take the rest of the tail because that was the action that we wanted to perform. We're going to give it I1, which is the de-incremented counter. And we're going to send it the rest of the answer. So basically what this does is it will continue doing this until one of these conditions fail. Since we don't de-increment n, this will never fail. And if n is already less than 0, well, we have this this statement to deal with that. But if n is greater than 0, and until I becomes 0, we're going to loop through this initial list and find the starting index that we want. Alrighty. So now let's state, okay, we have the correct index, and we have the rest of the list that is greater than n. So this is going to be when I is actually equal to 0. So this is at index 0. If length of L is greater than n. So if all these conditions are true, what do we do? Well, we actually want to start slicing this list. So slice. We have the head and we have the tail. We have 0 as the I index. We have n, and then we have a result. Okay. We know that n is greater than 0, right? Because if it was 0, it would fall under the first condition. We're going to take the length of the list and we're going to return it as the length. And we're going to compare. Is length greater than n? Right? This condition right there. If so, we're going to state a new n because we're going to de-increment this counter. We're going to say n1 is n minus 1. And we're going to slice t, which is the rest of the list, 0m, which is the de-incremented counter, and r. Now, there's something missing up here. We have the result, but we are now taking a slice out of this list. right? We're at the index we want, and we actually want to capture these elements. So what we want to do is we actually want to concatenate the head of the list with our result. So head is here, and then a result. And that would be the solution for that.
Wait, wouldn't you do N1 in the bottom slice instead of M?
Yeah, you're right.
Okay.
N1. Sorry. My messy handwriting. Thank you.
And also, where is L coming?
from? I
Yeah.
just realized that. I'm pretty sure you can
Should
do
be
this.
R.
Could you just pass in?
Yeah.
Just
H
put it
and
after
T,
the
though?
slice condition. Or before. Fine.
Oh wait, sorry.
It's
Could
the
you not
length
just
of
pass
R,
in
I
H
believe.
and T?
Yeah, you're right. Of R. And then I'm pretty sure this would work.
Wait, why is it the length of R? Because isn't that the elements that you already went through?
I think I could just do. I'm pretty sure this would still be valid.
Yeah, that's valid too.
Does this make more sense?
That makes
Perfect. Okay. So we have that condition where the length of L is still is greater than n. Now we have this case. If the given index is less than the number or less than the length of the list, give the rest of the list. Or like this is the case where n is going to be greater than the list. So we're just going to return the rest of the list. So I'm actually going to write that down. Sorry, I'm doing hashtags. I'm used to another language. If so, this is still going to have the same start. We're going to check at index 0 if length is less than n, return rest of list. Perfect. So now we're gonna go here. Okay. So now we know. I'm just gonna fill out what we know currently. We know that the index is 0. We know that we have an n value. I don't really know currently what we should start with and what we should end with. So we're gonna check, is n greater than 0? We already know that the index is 0. If n is greater than 0, we're going to get the length of, let's just keep it as L for now, L, and we're going to return it as length. And we're going to check if length is equal or if n is greater than or equal to length. Okay. If this is true, we're going to return the rest of the list. So we know what our return statement will be. It will just be L. And that is the whole question. That is the question as a whole. Does everybody understand each part of this? Because this is actually really important. I think he said that this question is going to be similar to what is in the exam, but the exam question is going to be it's going to be easier. So as long as you understand how to do this, you can understand that exam question. Also, some good practice, because since he said it was similar, and profs like to play these tricks. They say this is okay. They say they want to take a slice of this element. Think about other questions.
Maybe same thing without the n.
Yeah, that involve slicing. And try to solve this. Or it could be like, I actually have no clue. I was thinking like in ascending order. Like if you see this question,
slice it in two.
Yeah, slice it in two, or like split a list in half. Just any list you give it, split it in half. Or like you see how we have merged the content so that it is in ascending order. Try to do it in descending order as practice. Okay. I'm going to share this out. This is actually a Cookies and Cramp session, so thank you, John, in the chat, VP Academic, for inviting me here and allowing me to do this session. Okay. Anyways. Now, we're going to create a scheme function that performs the same tasks. So, as you can see, most of the Prolog and scheme functions are going to be side by side because the logic is the same. They're going to ask you, okay, you can do it in Prolog, do it in scheme. And you're basically converting this logic into scheme logic. And the easiest way to do this is to use a conditional statement, which I'm going to do right now. So they give us the start of the program. We're going to take the slice. We have our list, we have our index, and we have n. I'm actually going to change index to just be I, because I don't want to type out the whole word. Okay, so we're going to start with a conditional statement. Okay, what is our first statement? If n is 0, right here. If n is 0, we're going to return an empty list. So we know if it's equal n and 0, we're going to return an empty list. Okay, I'm just going to say, should the comments and scheme go this way? If n equals 0, return empty. Okay. Next statement. What was our next check base case? If the list is empty, we're going to return an empty list. So, if null L, we're going to return an empty list. Empty list. Okay. What is our next case? Well, we're going to check. Actually, let's do one of these first. Let's say if I is equal to 0. So if equal I is 0. And we have n that is greater than the length of L. So greater than the length of L and then n. What will we do? So if I is 0 and the length of n is greater than L, at index 0, if length is greater than L, return the rest of the list. So we're going to return the rest of the list. I'm just going to make sure I wrote this statement correctly. Okay. Let's just return the rest of the list, and then I will probably change that after. So we're going to return the rest of the list, but this is SQL. Not SQL. Scheme. We're going to return slice of... Okay, wait. Let me think about this a little bit. So we have the case that I is equal to 0, and the length of n is greater than L. So that we have to iterate through L. Up here, if length is greater than L, return the rest of the list. But I think we're doing this case right now in my mind. So I'm going to change that. Wait. I'm going to change this equality sign. Okay. We're going to return... We're going to concatenate the start of the list with the result. And we're going to return that. So we know that we're going to cons the car of L with the result. And the result would be the recursive call with the rest of the list. So we're going to take the rest of the list, and then we're going to take index, which is 0, because I is still equal to 0 up here. And we're going to de-increment our counter of n. Okay. And then we're going to deal with this last case, where I is 0, and n is greater than the length of the list. So else, we're going to take a slice. We're going to take the rest of this list. Wait. This is not else yet. We're going to take and equal I0. We have the sign now, length of L. We have n, and we're going to return the rest of the list. Okay. So we have those 3 cases, and it should be 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, we're missing a case. Else, okay, we have the case where it's n is 0. We have the case where the list is empty. We have the case where the I is equal to 0, and then the length is greater. And then the case that I is equal to 0 and the length is less. I think we're missing the case where we are actually doing this function. We're de-incrementing the I to get to the correct position of this list. So this would be perfect actually to be here. We have a check where I is equal to 0, I is equal to 0. These 2 conditions do not deal with I, so then we can let the last condition actually deal with I. So if I is not 0 and it is not in it does not fall within these 2 cases, then it must be greater than 0. So we can immediately go to where's the next step. So we're going to do select of the list. So we're doing this.
Using Golang, can you mute yourself? There's an echo, bro. Thanks.
Perfect. We're doing this case where we're de-incrementing I, and we're taking the rest of this list. See how the tail is here instead of the head? And we're shifting this list over and over and over until I is 0. So to do this in scheme, we know that I is not 0, because if it was 0, it would fall within these two conditional statements. So we know that it is greater than 0. So all we need to do is take the rest of this list, which is CDR of L, de-increment the index. This is going to be I, and then return the same n value.
Wait,
and
I
that
minus
is
0?
Yeah, that's I minus 0. Oh, I minus 1. Sorry, my bad. Thank you for that catch. My mind. There we go. And that is this slice in scheme. So even if you look at the practice exams, he gives us a lot of questions that are like, do this scheme, do this in Prolog. Start with a Prolog and then convert your answer to scheme, because that is the fastest way. Going from scheme to Prolog is like, it's the same speed, but it's harder to think about personally. So some tips: you're gonna need to review the chapter with structs, with Go functions. I do have a question that covers one of them, but know how they work. Know how to build functions with them. I say who instead of how. How to build functions for them, etc. And study set of and bag of within Prolog. And this gives me enough space to do some CDR, CD questions. Okay. Let's say you're doing this and of L, and let's say L is 1, 2, 3, 4, 5, 6. What is the output of this function? Well, you're taking the CDR. This is converted to CDR. Sorry. Every D is a CDR. So it's CDR one time, CDR second time, CDR 3 times. So what would be the result? Well, this first CDR will just take this rest of this list. Second CDR would take the rest of that list. Third CDR would take the rest of that list. And the result would be 4, 5, 6. Same thing with car. So car would just take the start of the start of the start of the list. I don't have an example for this, but this is just kind of what goes on. Let's say you're doing something like CADR. This is taking the head of the tail of the list. How will that look like? Let's say that you have the same list and you're doing CDAR. You're taking the start, or let's just replace this CDR of L. You're taking the CDR of the list, which will return you 2, 3, 4, 5, and 6. And then you're taking the car, which will just give you 1, or 2, sorry. And 2 is the head of the tail. Those are just some quick ones. Know how to read them, because he might just... let me actually pull this practice exam. Actually, I think I have it. I have some questions. See questions like this, which are easy to answer, easy and short. He might give you some of these that have CDR and CADR and all those combinations, and you must know how to deal with them. Okay. Now, he's going to give us a couple questions that are like, what does this function do? It might be in Scheme, might be in Prolog. Just take your time and read it line by line. Anybody have a question? Okay, we're good. So, we have... Let's go with purple. We're going to define test of L. And within this definition, we call test 1 L and 0. Okay, what does this test 1 do? Test 1 takes L and M. If the list is null, it returns M, that is 0. So if this is an empty list, we return 0. Okay. Else, if greater than... okay, so this is just another helper function. If greater than helping function, helper L, car L. Okay, if the return of test helper, which is going to be th, is greater than M, we call test 1 with the tail of the list, and then we call test helper, which is the same function, with L, and then the car of L, which is head of list. Okay, so let's see what test helper is doing. Test helper is taking the list and taking a constant, and you have multiple conditions. If L is null, you're going to return 0. Or the car of L is equal to that constant, you're going to increment the test helper by 1, and then you're going to call this function by CDR of L. So you know what this reminds me of? whenever I see like an addition to a recursive call or a concatenation to a recursive call, it always reminds me of this function that we went through. If I can find it. This one. Which is the same as this one. We're keeping track of a value. And in this case, you're keeping track of an integer. So you're saying that this loop is checking if constant occurs within list increment. Else go through the rest of the list. And what this is probably keeping track of is, or this step actually, is if that constant that is returned is greater than the current max, which is m. And then if it is, you're gonna append it to the rest of the list. Append the rest of the list, or call the rest of the list with m. And that will continue going through that loop of checking if that. So okay, this first line takes every element and checks the number of times they repeat. Okay. So what is this function doing? Well, this function is just checking. This function is just checking the max number of occurrences of every element within L. And that is it. Does that make sense for everybody? I know I went through like kind of quickly and jaggedly, and there was no like real reason to it. I just started reading the lines of code. If you do have problems with this, let me know, because these questions should be like almost like a bonus point in terms of its easiness. You should be able to like read a function. A good way of going through it is make your own list and make your own m and call the function. So pretend that you have all you would do actually is call in test and make a list. Let's say your list is 1, 2, 1, 2, 2, 3, 4, 5, and see what happens with that. Okay, I'm just gonna move on. Now this is one in Prolog. Sorry. What does this function do? Okay. So we have the occurrence of set of, which is important. I'm gonna highlight that. Okay. So we have a sibling. We know that one group of siblings is John, Mike, and Linda. We know the second group of siblings is Jane, Maria, and Harry. Third is Kelly, Brian, Nina, and James. When you call set of H, sibling H and T, where you're checking if the length of T is greater than 1 and you're returning B. So, and we know that B returns with John, James, and Kelly. So what this is doing, you can check it. This kind of gives you a hint. Or you can see like, okay, what do these three have in common? But you're taking siblings. You're taking the first sibling, John, and you're taking the rest of the siblings, and you're checking if it's greater than 1. So basically, you're checking if first sibling has more than one sibling. Sorry. And if so, you're going to return it. So let's check it. John has Mike and Linda, so that works. James, let's pretend this is James, because I probably spelt it wrong. James has Maria and Harry, so that works as well. Kelly has Brian, Nina, and James. That works as well. Alrighty. Now, does this do the same thing? Okay, no, because now we have t is greater than 2. So, in this case, we're checking if the first sibling, because the start is the same, has more than 2 other siblings. So let's check here. Or greater than 2. So greater than 2. So by greater than 2, that means if it has 3, it works. If it has just only 2 others, it fails this condition. And you see that here, John only has Mike and Linda. That's 2. 2 fails this condition, right? Because it has to be greater than 2. And then James, Mary, and Harry also fail this condition. And Kelly, Brian, Nina, and James actually succeed this condition because 3 is greater than 2. So all you return is Kelly. So this is what these 2 lines do. Does that make sense? Okay. Just gonna continue going. We have a shit ton of practice. Okay. So this is giving you a bunch of small functions and asking you what is the output. So we're gonna loop n is equal to 0, or n is equal to 4, sorry. I is equal to 2. If 0n, we're gonna return I. Else, we're gonna de-increment n by 1 and increment I by 1. So if you think about it, every time we de-increment n, we increment I until n is 0. So if you do 2 plus 4, because we're de-incrementing n 4 times and we're incrementing I 4 times, that is 6. So the result, when you have n is equal to 0, you return I, so the result would be 6. Okay. In this statement, let star L1 be 1, 2, 3, 4. L2 is the car of L. We're creating a lambda function called f. And f is basically L. F is just L, I'm pretty sure. Lambda of L, and then it returns L. Okay, that's a weird way. So when you're consing f of L2, which is just L, with L1, L2 is just the car of L, so it's the head of L. All you're doing is adding the start of L1 back to L1. So it would be 1, 1, 2, 3, 4. Okay. Now this function. We have a lambda function. We have x and y. And then we have these this formula. So in lambda functions, you define it and then you call it within the same line. So you define it and then you call it. So x is equal to 2. Y is equal to 3. And you go through this problem. So times x and y. So 2 times 3. This would be 6. This would be 6. And it would be 6 times 6, which is 36. Okay. Now we're going to go through this problem. Let A be this list. So A is equal to the list of 1 and 2. And we have conditional statements. Is the CDR of L a null? No. This fails. Okay, this is actually a good problem to go through because it has CDR, CA, DR. CA, DR is basically doing car and then CDR. If you take the car of this list, you're returning 1. If you take the CDR of 1, you're left with an empty list. So is that equal to 2? Or is that still a list? Is an empty list still a list? I would say yes. But my heart is telling me no. Let me actually quickly look that one up. List. I'm pretty sure it's no. The list is nothing more than a sequence of item. Okay. I'm gonna go with no until otherwise, because we always check if it's no. And I don't know. Sorry. Oh my god. Now we're going through the next statement. We're doing CDR of A twice. When you do CDR of A, you're taking the tail of the tail. And okay, A is 1 and 2. So we're gonna do A is equal to CDR of A. CDR of A is 2. And you take the CDR of A, you're also left with an empty list. So that would also go. I'm pretty sure this would return 2, because the first one would actually succeed, because an empty list is still a list. Because you're taking the car and then you're taking the CDR.
I think it's the last one because the second line, when you do car, you're turning an atom, not a list.
Okay, thank you.
And the third one is just checking if the empty list is a list, which is true.
Empty list is a list. Thank you, thank you, thank you. I didn't know that car returns an atom. That makes sense because you're only expecting a singular element.
Yeah.
Okay. That is. See, I learned something today. Nice. Car returns atom. Thank you so much. Okay. And this one, you're consing, so you're concatenating two lists. You're doing the car of 1, and then this is a. Oh my god, is the brackets correct? Holy shit. 1, 2, 3, 4. Holy fuck. Okay, 1, 2, 3. Okay, they're both messed up. That's it. Oh, because we have.
You're not counting the bracket
Yeah,
before
yeah.
car and the one.
I see.
They should be
I
alright.
just
No,
wanna.
it's not the.
Oh, not the very
You
last
start
one.
from
Yes, you're right.
cons.
You're right.
Yeah.
You're right. Okay, yes. Okay, I just want to make sure I know what I'm concatenating.
Okay, you're doing car of 1, and then you're doing cons of the car of 1 and 8.
Okay, thank you. Okay, I know
I
what
think that should
okay,
be
I see.
no problem.
So when you do car of 1, since 1 is embedded within like a second layer, so guessing this is it, or it's the last one. See, okay, we're taking 1, and we're doing the car of this. If you do the car of this, you're taking the first element. The first element of this would be just 1. And then you're consing it with this enlarged element. So you just add it the same way. When you're consing two lists together, you ignore the first bracket, and then you cons it as normal, pretty sure. So this would just be 1 and then 8.
Can you test this one on Dr. Rocket?
Yeah, I will right now, actually. So I feel like the brackets are throwing me. Okay, I'm gonna just bring this into my screen. You guys will get this, probably this whole like document at the end. I talk about every single function, single scheme function here. And I'm just gonna quickly write it down. I think if I do... Actually, I can just run it, and I think I can just run it in command. Okay, ignore the rest of those outputs. I'm gonna pop this up. Just gonna take it half screen for now. Okay, we're gonna do the cons. I'm gonna just erase what I wrote so I can easily see what's going on. Honestly, I hate questions that have like so many brackets for no reason. It's only testing your ability to read code or like to digest.
It's also how to understand how cons works when you have multiple lists.
That's
instead of-
true. That is true. Like, it is a good question.
Yeah,
I just
hate
Okay,
it.
so that's the first unit, and then we have the second one.
I think you missed a parenthesis in your answer.
I probably have. And then this is the last one.
No, I think
So,
it's the good amount of parentheses.
so
Yes,
this
there's
is
3
actually what it
there, 4
returns.
there. Yeah.
Let me just copy that down.
Yeah, you missed a few in your answer.
Yeah, I did. I can tell. I think the brackets got me cooked.
No, you got the opening brackets right. You just had to complete the closing ones.
2, 3. Okay, thank God.
Yeah, that's perfect.
Okay, so you're taking the first element, and the first element would be, pretty sure it's just this, and then you're taking this whole thing, and you're consing it together. When you cons a list like 1, 2, 3, and you cons it with like 4, it's almost like you're ignoring those first brackets and you're taking the elements within it and you're concatenating them. So the result would be 1, 2, 3, 4, right? And I'll
I'm
express
pretty
my
sure in this case it would be 1, 2, 3, and then another bracket for 4. You can test it.
Yeah, I'll test it. Let's just...
Because left side
We
is
have
the first element, so even if it's a list, I think it's gonna take a list. I'm not
here.
sure about this.
It's good. We can test it quickly. 2, 3, and then we go 4. Sorry. Oh no, you're right. Yeah, you're right. Okay, that is something new as well. We take this. Okay, so you concatenate the first element with the... Okay, so I'm guessing that's why this looks
You
so...
can ignore the brackets in the second element, but not in the first one. That's the rule.
Brackets. In first element? Or in second element, sorry. In... first. And by ignore brackets, it's ignore the first layer of brackets. Ignore first layer of brackets. Of brackets. Okay, let me just extend this again and highlight this note. Perfect. And let me just drag this, full screen it again, and go up here and highlight the note about atoms as well. Okay. Okay, let's see what this question is asking us to do. We have Q5. When you give Q5 a list, you see that it's only replacing these two letters and the rest of the list stays the same. And you see it's the same for here. You're just replacing this element with that element. If it has a single element, you're returning that single element. And if it has an empty list, you're returning that empty list. So in this statement, if we have an empty list, we're just going to be returning the empty list. Okay, in the second element, if we have only one element, right, null, if the CDR is null, that means we only have, or if the CDR of a list is null, that means we only have one element in that list. And if we only have one element, we're returning that list. Now we have the else statement. So else, we're going to take the head of the tail of the rest of the list and replace it, or we can say swap it, with head of list. So in this case, you can make some probably let statements. Let A be the car of L. Let B or be the car or CDR. CDAR. So you're taking the head of the rest of the list of L. And then you can concatenate cons A, or you're consing B, and then A, and then you're also doing the rest of that list. So taking the rest of the list after those first two elements would be CDR, and that would abbreviate to CDDR. So
Wouldn't it be CADR for let B?
CADR. Actually, you're taking
Because
the
if
second
you
element.
do, yeah, but to get the second element, you're taking the car of the CDR for CADR, right? So if you're just doing CDAR, that doesn't work on like a list with like two elements or anything. You would actually get an error.
Okay. Let me think about that. CDR. Okay, so you're taking the car and then the CD.
Of the CDR, it's like if you took CDR first and then you took the
Okay.
car of that, so that gets you the second element in the list, or
Okay.
the head of the tail.
Yo, thank you. I thought the order always goes from left to right in terms of when you take it. So
I think it's like if there was parentheses, like there would be
Yeah.
parentheses over the CDR and then parentheses over the car. So it is left to right, but it's in parentheses, so it's
Okay.
goes right to yeah.
I see. Okay, that is something that I learned as well. Okay, thank you so much. So I think this would be it. Wait, you're consing the LB and then you're taking the CDDR of L. And I'm pretty sure that would be it. There is a different solution in the final. This one kind of makes the most sense, where you're just taking every variable and then you're selectively concatenating them. But the solution in the textbook, I think those, or like in the final solution for this line, goes something like else cons. You take the CADR of L, which, like they said, is the head of the tail. And then you're consing that with the car of L. And then the CDDR of L, which is the rest of the list. So, yep. Okay. Man, CADR is taking head of tail. Alrighty. Not Kate's tail. I think we have a lot of more questions to go. But that's okay. We just keep working through them. Okay, so last two returns the last two elements. And I'm guessing they want us to do this in scheme because this is scheme notation. So let's try this. Define last two. Or two last. I'm just gonna call this TL for short. So two. Actually, let's just do the full thing. I have time. Two last. And what this takes is a list. Okay. We're gonna have some conditional statements. What we're gonna do is check some base cases. Usually when you're working with lists, you're gonna check if that list is null. If that list is null, you're just gonna return L. Let me just check. Okay. And it's the same thing. Let's check if it only has a single element. Null of CDR of L. If so, we're just gonna return that singular element. And for this case, we're gonna make sure that we have at least two elements left on the list. So to do that, we're gonna check if there's gonna be a null when you take two CDRs of L. And if so, you still want to do the rest of the list. And you're basically progressively checking until this fails. Or, yeah, until this fails. So that means that when you take CDR of this, you get 2, 3. You're checking if this is null. If so, we return the rest of the list. And then this would be pretty much succeeded. Else, we call 2 last. And then we just do it with the rest of that list. So when we get to that case, or this case, we're actually returning 4 and 5 in this list. This de-increments. Till that point. And these two steps only occur at the start. Because if you're given an empty list, you return L. If you're given the CDR of L is empty, you return the list. Else you just keep iterating through until you get the last two characters. When you take the CDR of the last two characters, well, the first one, you have 5, and if you take the CDR or if you take the CDR of 5, you get nothing. When you have that case, you're in this statement, and you're just going to be returning that list already. Following function that searches a binary tree.
I think we don't have binary trees in the exam.
Okay, thank God.
French prof sent a mail saying we don't have binary trees in exam. So, do we have the same exam?
I think we do. He gave us your practice, but I don't think our prof relayed that we have a binary tree, or not.
My prof relayed it this morning.
Oh shit. Okay. So guys, we don't have a binary tree. Should I still go through this question or no? I feel like it's okay if I don't. I think it's pretty much just wants you to return the subtree rooted at that element. If you're just asked to return the subtree, instead of returning true or false, if the tree is null, you're just gonna return empty list because the subtree would be empty. If you find the variable, and it's equal to the car of the tree. So you actually found the root node that you're searching for. You're just going to return the rest of the list. And I think that is it. Else, if none of these statements work and you don't have your element within the tree, you're going to return an empty list already. Okay, now we have this one. So this is actually using structs, which is important. My prof, okay, Couture, my prof said that the only Go programming question, is going to be a bonus.
Seriously?
Yeah.
My prof said nothing about it. Like, he gave us a few things to study in Go. Because the thing is, you guys did scheme first, we did Go first.
Oh shit.
So it's kind of... Do we even have the same exam in this case?
I think we have the same exam. I know for a fact we have the same exam.
Then it doesn't make
Really?
sense to only have 1 or 2 questions on Golang for us. Because we studied more Golang than anything else.
Did he say that how many questions you guys are gonna have on Golang?
Nah. He
Okay.
said no, nothing precise. He just told us study this for this lang, this for this lang, and that's it.
Damn. Well,
He said 3 to 4 for each. for
okay.
us.
That's not that bad. This question you're just gonna define an add that enables the addition of a book. This is actually a really important concept with structs. When you're gonna define a function with structs, so this is gonna be in Go. I'm gonna get a more readable color. You want a pointer to the original object. And then you want the object that you're actually reading. And then this is your return statement, because if you look further in the question, the number of books you read is going to be the return of that call of add book. This is a very important concept. Unlike a traditional function that would be called like this, add, and you can just call it. You can have like n books. This one is actually related to an object. You do jack dot add. So in order to actually capture this object, you have a pointer to that object that you can use to access it. That's why you have this initial start of reader star or r star reader. This asterisk is a pointer to that reader object. So it's actually more towards this side. And you will cover probably pointers and aspirins or whatever, capturing the value or the address in C++ if you take it. But this is a pointer to that object. That's all you need to know. Whenever you're defining a function for structs, you want to have the pointer to the object so you can access it. And we access it within this line where we're going to get the books. And we're going to set it to a new variable where we append r.books with the book that is we want to add. And then we're going to return the length of the books that we currently have. And if you see up here, when you do r.books, you're getting this statement in return, and you're returning the length of the books because you're using it here. So even though he gives you just a simple, like the simple problem of create this method, you should also read the whole program to see what this is doing after you call it. because if you leave the program as just adding this book, which is obvious, and you don't return the length of the books, you will lose marks.
I had a question about this.
Yeah, for sure.
The line that says like Jack equals reader, when you initialize the list of books, are you filling, like, is it a list of 5 that are filled with zeros, or are you just putting the like max length?
This is a list of 5 filled with zeros.
Okay, so when you're
It's
appending,
like, yeah. It, like, in this case, you're saving space in memory.
okay,
Space of memory, you're making an object book that has it contains 0 and then it's 5 of them, so it's like book. If you're just gonna pretend that you're accessing it, it's gonna be 0 0 0 0 0. That's pretty
so
much
would
it.
appending it be like adding books after the zeros, or
Yes,
replacing?
I'm pretty sure
okay.
it's adding books after.
Okay.
I can double check, but that's like my first instinct.
Yeah, so I
Even
think
here,
the prof went over this and he said the same thing, but I was just wondering.
yeah.
Yeah.
Even here, you're actually adding a title. Like, I know make from C++ or like something similar is just saving memory. And it will be like 0 0. It's almost like you're doing an int. And you're just creating the list of like I forgot how it's called or how it works, or my brackets and probably in the wrong spot, but it's like doing 5 in here when you're creating a int list,
Oh, okay.
whatever. I forgot the syntax, but yes.
Yeah, I know what you're saying. Okay.
Perfect.
Thank you.
This would just create a empty list with 5 and actually I think it would be filled with null values instead of zeros, but yes, this is filling it with zeros. Okay. Back to this. Go routine and channels. So below is a go function which describes the computation on elements of an array by parallelizing the loops in 2 competing threads. So you have this function, your import fmt, which makes you print statements work. You have the index and the value in the range, and then you're setting through that channel the index plus the value, and then you're closing this channel once that process is done. And you have one channel. You have your list of integers with 1, 2, 3, 4, 5, 6. This is splicing this list of integers into the first 3 and the last 3. So it'd be 1, 3, and then 1, 2, 3. And then you're accessing these values. You have a value and okay. If the channel returns, it will return a value. If there's nothing, it will stop. And then you're printing that value. This value is the concatenation. So let's see what it prints. In run 1, it prints 4, 6, and 8. If you look at here, it's concatenating its index and its value. So it'd be 0 plus 1, which is 0. 1 plus 2, which is 3. 3 plus 2, which is 5. And then for this one, it'd be 1 plus, or it'd be 0 plus 4, because this is a new list, right? New list index changes. This would be still 4, sorry. Then we have 1 plus 5. This would be 6. And then 2 plus 6, which would be 8. As you can see here, we only print 4, 6, and 8. And in run 2, we print 4, 6, and then 1, 3, 5. This would be 1. So as you can see, the Go channels are not completing before the program is exiting. Now, they ask us to fix this problem by making 2 channels. And they actually make these 2 channels for us. So it's relatively simple. All you want to do is just make sure that these 2 channels are outputting and that you're printing these variables. So you're almost doing like a carbon copy of this statement. But you're doing it probably within a switch case. Select. If you have case 1, which is going to be case of value from channel A, and we have OK. And we're taking the output from channel A. If OK, we're going to print that value. And then we have the same thing with case of B. Sorry, I was spelling okay instead of just okay. I don't think it'd matter. And then we're taking the output of channel B, and if it's okay, we are printing that output. And this will basically go until these two channels have done their processes, or well, both channels have done their process, and then both functions would have ended. So we'll go to the very end until both channels are done. And how do, like, even if you don't know how to program Go, if you just look at what they give you, value okay, and then you exit from one channel, if not okay, you break, if okay, you print, you will understand what you should do within these two select statements. Right? You could probably do this not even in a select statement, you could do it in another way, as long as you just keep this infinite loop, which is given for you. But this, you take it from the original problem, you just fit it to work with two channels. Okay. And that was it. That was all I had prepared. If anybody has any like questions about the exam, about Prolog, about Scheme, about anything, let me know. I'm gonna check the chat as well. Did we skip page 9 on the PDF? Let me check. Oh, what shameful plug. Oh shit. Oh yeah, guys, everybody. I'll let you know. I have the best server around, okay? The most popular server. Nobody has been banned on the server. You know, it's a ban-free zone, okay? Sure, code.
It's pretty nice.
It is pretty nice. It's pretty friendly. Everybody answers questions if you have them. It's the hotspot for courses. And it will be here during the summer. So if you have summer school, or if you fail this class, feel free to join the server and ask for help. I don't know if this class is even available during the summer. Let me just quickly. Okay, if anybody wants to scan that QR code. Also, I gotta give a shout out to Big Horse. He's hosting a party. I think on the 26th after exams, and the link is in my server. So if you want to buy tickets, feel free. He's a good rapper. Who else should I shamelessly plug? Big thank you to IEEE for letting us host this event. Sorry you guys missed out on cookies, but there was like maybe 20, 25, 40 people in this call right now. And if we were in that cramped room, it would suck. Alrighty. Anything else that I should shamelessly plug, or?
Ah, you're good. You got 4 people coming over.
Hell yeah.
5 now.
Hell yeah. If it does not work, I have banned you. I'm sorry.
Ban me?
No, I'm just saying, like, if people scan this code and it just did not work for them,
Mm-hmm.
I probably banned them. Okay. So I'm sorry. I hope you
It's
guys.
a ban-free serve, by the way.
Yeah, ban-free server. Ban-free server. I hope this review is very helpful. I'll stay here if you have questions. Make sure you do the prologue final. Okay, don't miss out on that. Let me just quickly sign my name somewhere on the sheets so they know it's like. Let me just go here. Gotta get that big thick marker. And let's go with some nice yellow. From foobar and grill. And then let's just there we go. Now I can save this. This is gonna be filled. Okay. I'll just keep that one up. And I'll also give you guys my Steam thing shortly. I'm gonna post these solutions in that Discord that I have up here. It's gonna be in the Paradigms chat. And if Volvo, if you can send me that recording, I would appreciate it. I think we covered some helpful things. I also learned a little bit, which is nice. Like I didn't know the thing with car, how it atomized the list, and I almost forgot how to concatenate or how concatenation works. But I was able to figure it out. And the CDR, so you do CADR to get the head of the tail. I thought it always worked from left to right, but I guess it's just the way the brackets are.